Hello, welcome to the demo video of our project. Firstly, we would like to thank all the judges for giving us an opportunity to present our project at such an amazing platform and recognizing our hard work. Now, let's get to know our project in greater detail. Past decade, there has been a tremendous increasing usage and research of wireless technologies, along with making our lives easier and our workplaces less messier. It has brought along with itself a major risk of hackers interfering in the networks and catch hold of our credential and private information which they aren't entitled to. Such penetration and interference is done by launching various attacks such as Sybil attacks, black hole attacks, and many more. Out of these, the most dangerous attack being the wormhole attack. This attack is destructive enough in which it manipulates routing tables with false entries, making it very difficult to detect. Hence, we decided to attempt to design an algorithm to detect this attack. Hence, we present to you a project, NRIS, a novel hybrid mechanism for detection of wormhole attacks in wireless sensor networks. Now let's understand what a wormhole attack is. Wormhole attack is a denial of service attack launched by malicious nodes by creating a tunnel through which the packets are replayed to the malicious nodes, disrupting the communication channel and corrupting the network routing. It is a critical attack where the attacker enumerates the packets of a locality and transports them to another place. So, as you can see in the image, the wormhole tunnel causes the packets to bypass their normal route and pass through the tunnel because it seems to be the shortest path to them to reach their destination. Now let's quickly understand what we have proposed as a solution to this problem. In our proposed solution, we combine two different concepts. That is, the concept of the neighbor ratio threshold, or NRT as it is called in our base paper, and the concept of performance metric analysis. As we'll see in later parts of this video, this combination proves to be immensely useful as it eliminates the need to scan all the nodes in the network, which totally makes the process worthless in case of large networks. Let's come to the system design part. Firstly, the technicalities. We have fully developed the project on Ubuntu 16.04 operating system using the Network Simulator 3 or NS3 simulation platform. For the coding part, we have used Python 3 on PyCharm 2018.2 integrated development environment. Now let's come to the system structure. Our project is logically divided into two phases, collectively consisting of three stages of the process, as you can see on the image. Now we'll go through the stages one by one. Let's understand an important term first. You will often come across us saying a network exhibits wormhole characteristics. What we mean by whether a network is exhibiting a wormhole characteristics is that the performance metrics show certain trends initially and finally. You can see that the average throughput and the PDR of the network decreases after the launch of the wormhole attack, but the average end-to-end delay increases many folds. If these trends are shown by our network, then we conclude that our network exhibits wormhole characteristics. Now, coming to the phase 1 of the project, the phase 1 consists of the basic network initialization, which includes the configuration of nodes in the network. It also consists of the stage 1 of the project, which is the performance metric analysis of the overall network. Now, by performance metric analysis, what we mean is that we are going to analyze three performance metrics of the network, namely average throughput, packet delivery ratio, and the average end-to-end delay, at two different points of times, let's say initial and final. To get the performance metrics, we send a certain number of packets, in this case 50, starting with an initial count which is 5 for now, and then increase the count of the sent packets at each traversal by a certain step count, which is again 5 in this case. As you can see, the top left terminal on the screen is collecting the initial parameters from the simulation environment, and similarly the bottom left terminal is collecting the final parameters. What you can see is the result of the execution of a file named wormhole.cc, which runs on the NS3 platform. At this stage, we analyze the overall network and check whether the network exhibits wormhole characteristics. And only if it does, then we proceed to phase 2. Hence, in a way, this mechanism provides a dual filter to the execution process, making it less resource and time consuming. It is a waste of energy to check whether all nodes are affected by wormholes for fewer nodes which are actually affected by the wormhole attack in the entire network. The wormholes will increase the connectivity of the network, and an obvious increase will be seen in the neighbor number. Therefore, the neighbor number of a node within the impact scope of the wormhole will be more than those not within it. We use the proposed neighbor ratio threshold to compare the neighbor number of a node with all its neighbors to avoid launch wormhole detections for all nodes in the wireless sensor network. Now, how is this done? Every node in the wireless sensor network will know its neighbors after the neighbor discovery. Then, the node calculates the ratio of its neighbor number and the average neighbor number of all its neighbors and name this term as neighbor ratio. Finally, this neighbor ratio will be compared with the neighbor ratio threshold to determine whether the wormhole detection is required or not. What exactly must be the value of the neighbor ratio threshold or NRT? NRT of a network ranges from 1.1 to 1.5. What you are seeing is the snapshot of a base paper in which the authors have concluded after much experimentation that it is better to keep it as minimal as possible, as it will rule out the possibility of a malicious node getting skipped. Hence, we too have kept the value to be minimum, which is 1.1. Let's continue with the demo where we left off. Our phase 1 suggested a possibility of a presence of wormhole in the current network. This is visible from the graphs shown on the screen. The three performance metrics showed exactly the same behavior as it happens after a wormhole attack. The average throughput and the packet delivery ratio decreased from the normal range, and the average end-to-end delay increased many folds. Hence, we proceed to the phase 2, which consists of the stage 2 and stage 3 of the project. In stage 2, we shortlist certain nodes which are supposed to be scanned and are suspicious to be malicious, using the concept of the neighbor ratio threshold explained earlier. In stage 3, pairs of nodes from this set of suspicious nodes are formed and are isolated one by one. By isolation, what we mean that the coordinates of these nodes are changed to be far away from the 250-meter communication range of each of the nodes enumerating in the current network. For this stage, we designed our own algorithm which takes a very intuitive idea into consideration. If the isolated node pair is not malicious, the remaining network will still have the characteristics of the attack persisting in itself. However, if the isolated pair is actually malicious, then this wormhole character will disappear from the remaining network. Simple, right? As you can see, our algorithm worked in the following way. It shortlisted our suspicious node set in stage 2, which came out to be consisting of the nodes 2, 3, 5, and 6. And then the stage 3 scanned pairs of only these nodes and found out the suspicious node pair to be 2 and 3. So you see, in the domain of network security, we amalgamated two different concepts and devised a mechanism with which detection of a wormhole attack in wireless sensor networks was much less complicated than the existing solutions. It is simple, built on open source platforms, does not require any external hardware devices, nor does it require some high performance computing setup for calculations. Python is a powerful language, and that itself was enough for us. This project can be extended in future in many ways. Firstly, we have only focused upon the detection part here. It can further be extended to even eliminate such suspicious nodes. Next, the performance metrics of the data can be used to get some advanced detection methods using machine learning and artificial intelligence also. At the end, we are confident that the project was interesting enough to keep your eyes and attention glued to the screen. Thank you for listening to us so patiently. Have a good day.